Woo, class! Welcome back to Mr. Haven's Physics Hour. So this is our next lecture on circuit. It's position versus time and velocity versus time graphs. It's going to help us put some of this stuff together about velocity and time and position versus time, and we'll go from there. So some questions to consider. What is a position versus time graph? It's simply a graph that marks a position over a certain amount of time. What is a velocity versus time graph? That is how fast we're traveling over time. How do features on one graph translate to other features? We'll talk about that. So a position versus time graph. It shows an object's position as a function of time. The x-axis is time, the y-axis is position. So imagine this ball rolling along as the strobe light goes. At time 1 second, we're at 1 centimeter. Time 2 seconds, 2 centimeters. Time 3 seconds, 3 centimeters, so on and so forth, all the way up to 10 seconds and 10 centimeters. Now we want to graph this. So we simply would create a graph. We would mark our y-axis as position in centimeters, and you see our divisions are 1 through 10, and then our time is on the x-axis, also 1 through 10. So position 1 and time 1 are 1, so we do there. Then 2 in 2 seconds, 3 centimeters, 3 seconds, and so on and so forth till we get to the end. So then, after we plot this, we have a plot of what our graph is doing. This graph shows a constant velocity, and we'll talk about that because the slope of a position versus time graph is equal to velocity. So we could use this to calculate our velocity, and we'll talk about that in the future. So there's our line, shows exactly where we went. What are the characteristics of this graph? A straight line upward slope. So what kind of motion created this graph? And it would be constant speed or constant velocity, depending on what we're talking about. So for it to be a straight linear line like that tells us it's at a constant speed or constant velocity. Each type of motion has a characteristic shape on a position versus time graph. So if I'm at constant speed or zero speed at rest, accelerating and speeding up, decelerating and slowing down. Going back to that, so those are the 4 different types of graphs we could have, and we'll have demonstrations of those later on in the PowerPoint. So constant speed is represented by a straight segment on the position versus time graph. That is constant speed. So it's traveling at a constant speed, say 10 meters per second at this speed, or if we were talking about velocity, it's 10 meters per second upward, or 10 meters per second away, a direction. This is constant speed in what we call the negative direction, or traveling back towards something. So it would be a straight linear line in the negative direction. This is constant speed represented by an object at rest. Our position is not changing over time. So this object is at rest. You can tell that by having a horizontal line to your x-axis. So curved segments on the position versus time graph mean the object speed is changing. So we're no longer at constant speed. And those are parabolic shapes. So if it's speeding up in the positive direction, you have a parabolic shape that curves upward. If it's slowing down, or not slowing down, if it's speeding up in the negative direction, then it's going to curve down towards the x-axis. So simply you think of that timeline there as almost like being the origin, and we're traveling back to the origin and past it if we're speeding up in the negative direction. A curved segment upward traveling in a positive direction but slowing down means our parabolic shape, it's going to kind of take that, it's like it's flattening off. So it's a little bit different than the last one. As you can see, the curve went upward there at the graph on the left. Now the curve goes different. The parabolic shape is downward, so it's got the concave part towards the time side. So if it's traveling in the negative direction, just like we saw on the previous one, that curved parabolic shape is the one way, and then when we're slowing down in the negative direction, it's going to come down to a flat line again, just like in the one on the positive, just it's in the negative direction. So the slope of a position versus time graph is equal to the object's velocity in that segment. And we can calculate that velocity picking 2 points on our graph if we wanted to. So they chose these 2 points, and the slope is a change in y over a change in x. You already learned this in your geometry classes or some other math class. You should already know this. The change in y over the change in x. The position is the y-axis, and the time is the x-axis. So at position 2 is 30 on the position side, and position 1 is 10. So it's 30 minus 10, final minus initial. And then the final time is 30 seconds, and initial time is 0 seconds. So then the slope is 20 meters divided by 30 seconds. And so our slope is 0.67 meters per second, north, east, west, some direction, positive direction, negative direction. But just remember that velocity has to have a direction because it is a vector quantity. So here's a position versus time graph that corresponds to an object moving back and forth along a straight path. And you should be able to describe the movement of this graph. So I want you to do that in your notes now. Pause the video and then restart it after you're done. Alright, so we're going to move on. I'm not going to describe it here on the video. We're going to talk about this one in class. I want you to tell me what kind of movement caused that graph. A velocity versus time graph, that's the other graph we're going to talk about. It shows an object's velocity as a function of time. So a horizontal line then means constant velocity. With the position time graph, a horizontal line meant constant position. We weren't moving, it was an object at rest. Horizontal line now, on a velocity versus time graph, we are moving just at the same speed. It's like being on cruise control. So a straight sloped line equals constant acceleration. So acceleration is a change in velocity over time. So the slope of a velocity versus time graph gives us the acceleration of an object. So positive slope, we get a positive acceleration. Not necessarily speeding up. Well, it's positive acceleration. A negative slope is negative acceleration and not necessarily slowing down. So here's a horizontal line on the velocity versus time graph, and it tells us that we have constant velocity. So if we have constant velocity, then that tells us that we have zero acceleration. So this object is moving at a constant velocity north, because velocity has to have a direction. This object, because of its position, is moving at a constant velocity south. If you look on the y-axis of velocity, it shows the north and south on either end. So that's how we know which direction it's traveling, north and then south. So if an object isn't moving at all, its velocity is zero, and so then it would be a straight line right on the x-axis because the object is at rest. That means no velocity, no acceleration. So if the velocity versus time graph has a positive slope, the object is undergoing acceleration in the positive direction. So if v is positive also, the object is speeding up. If v is negative, the object is slowing down. So you can have negative acceleration. So here's the velocity versus time graph with a positive slope. It has a positive velocity and a positive acceleration. Therefore, the object must be speeding up. It is accelerating. So we have a negative velocity and a positive acceleration. So the object is slowing down at this point. So negative velocity, positive acceleration means we're slowing down. So if the velocity versus time graph has a negative slope, the object is undergoing acceleration in the negative direction, or sometimes we'll call this deceleration as well. So if the v is positive, the object is slowing down if we have a negative slope. If the v is negative, then the object is speeding up. So we'll show these graphs. Here's a negative slope. We have a positive velocity because it's above the zero line there, and a negative acceleration. So this object is slowing down as a function of time. Now we have a negative velocity and a negative acceleration, so it's just moving in a direction away from the origin, so it is actually speeding up. And that is the end of our position versus time graph and velocity versus time graph